We're doing a quick recap here, what we did this month. And here you see it. I talked about distance traveled. And I'm saying that distance traveled is not distance. They called it distance, but they're talking about distance traveled. Okay? And what they're talking about is something in motion. Because what do? They measure. Okay? What they're doing is really stretching the measuring tape. Okay? And what we're looking at is the end of the measuring tape rolling across something, whatever, because they need to put a value like 10 meters in an equation. They can't put a qualitative concept like separation in an equation. So every time you listen to distance, you better think distance traveled. We're talking about motion. And when you come to think of it, there's no difference between that so-called distance, which is distance traveled, and displacement, position. What is position? Is position a static concept that you've got like a location? Absolutely not. Position means it's a what is it? Two numbers that you need to get to where the treasure chest is. You have an X and a Y. Yeah, it's a set of coordinates, an ordered pair or an ordered triplet or whatever. So all those are synonyms really, because in every single case you're talking about motion. Okay, and we talked about velocity. What was velocity? Well, velocity is equal to speed plus a qualitative concept, which is direction. And so you can't have velocity without direction. And so, the way they do that, they calculate velocity. And how do they do it? Well, they take the derivative. Okay, they take the derivative and they end up with this value. What is velocity? What is that value? It's a single point in a single point in time and in space. And what does that mean? It means that single point has direction. And how can you have direction on a single point? What they're doing is, see if I have it here. This is what they're actually doing. Okay, you have to have smiley pointed in some direction because if you have only the ball, you don't know what direction it's pointing.
Or where it's going to go.
So velocity has that smiley face in some part of the ball because you have to know what direction it has. But there you see it at the bottom. It's a movie because you're talking about velocity, which is a dynamic concept, but you're only pulling one point in the movie, one frame of the movie. And so the only way you can get that to have direction is putting a face to smiley. Otherwise, you don't have direction. See, the issue here is that in order to have direction, you need at least 2 points. Okay, you need a reference. Time. Yeah, you need a reference point. You need 2 points to have direction. Every concept really has to have two objects. That's what a concept is. A word that invokes or embodies two objects. And so to have direction, you have to have 2 points. But velocity is only a single point. Why? Because it's a calculated value. Okay, and so I explained that in a couple lectures ago. Okay, so you can look it up and you'll see what I said about that. Okay, anyways, that's velocity. And then you have time. And that's what we covered the other day, and lots of questions came up with that. A lot of people tried to define time. Let's see what they came up with. But first, let's find out what I said. I'm saying that time was calculated from speed. They just turned the equation around, and what you have is distance traveled divided by speed. What are we talking about? What is distance traveled? It's motion. What is speed? From a qualitative point of view, what are we talking about? Again, we're talking about motion. And so there you have my definition. It's a comparison of two motions. That's what time is. From so that you comprehend the notion. What do we mean when we say time? We're comparing two motions. And I gave the example of the second on the clock compared to the Earth going around the sun. And so when that tick mark, when the hand goes one tick mark, the Earth went 30 kilometers. That was the original notion. Today we have the cesium wave. They look at that, but originally it was geared to the rolling of the Earth around the sun. And what we did, we partitioned the year into days, into hours, into minutes, into seconds, and that's how we came up with the second originally. That's where we have the standard of the second. And then again,
it would have been pretty silly if we looked up to the sun and said, well, the sun moved 5 meters, so I guess we kind of had to chop it up into little pieces. Like, how much did the sun move? How much time has passed?
And the question is, if one of the things you got to think about is the Earth rolling around the sun. Is that a perfect? In other words, does that vary at all? By 1 second, even.
We have daylight savings time and stuff.
No. I'm talking about.
Sorry, about the whole thing?
I'm talking a little more accuracy here. I'm saying, or precision. I'm saying, does the Earth rolling around the sun ever change at all by even a fraction of a second in a million years? Does that change, or is it always faithful, always rolling around the same?
It probably does. My bet, if someone asked me that, yes, it changes.
It changes. I would think it's so too. But for the 200 years or 300 years we might be living, in a given period of time, it doesn't change that much. So it probably doesn't.
Negligible.
Yeah, it's negligible for all practical purposes.
But the Earth around the sun is one motion. What do you say? Time is two motions.
The Earth around the sun is one motion, but we
that
don't have
time?
time yet. So far, we have motion only.
But is
The
that
only
time?
way. No, it's not time. That's my point. My point is you need another motion to compare against that. You have to have a comparison of two motions in order to have time.
But when
You need
s-
memory.
But when you say a year passed,
Yeah.
that's two motions because of memory.
Yeah, but what do you mean by a year past?
Like if the Earth goes around the sun once.
Yeah,
that's-
that's called
one-
an orbit in
Yeah,
physics.
yeah,
just
that's
one orbit, right? So far we have nothing.
But isn't that one motion?
So far we have
And
motion.
that's 1 year, isn't that time?
No, a year has something else. You know, you need to compare it against something
Why?
like the seasons or something, because all you have is orbit and you don't have time.
If the
so
Earth
far.
goes around the sun once, that's
Yeah.
a year, which is time.
No,
which
but
is
you
one
call it a
motion.
year. Oh, so far you have orbit. Now, don't call it a year yet.
Why not?
Because year is a time thing.
Exactly.
So, and what do you have for you? What do you mean year? What is this year thing? All we have is an orbit.
Earth going, yeah, one orbit is 1 year, is what I'm saying. That's one
Yeah,
motion.
yeah, it's a synonym. That means year just means one orbit.
Yeah.
Good. We don't have time.
That's
All we have is
one-
orbit. We have motion, circular motion, but we don't have time. In order to have time, you have to have that second or something related to that. You have to have a comparison to that orbit. Then you have time. Otherwise, all you have is motion. You know, if I move, if I'm the only object in the universe, and well, you can't even do it with that because if you have a single object, you don't even have motion.
Yeah.
You need some other object in order to have motion. But then, if you have only two objects, one moves with respect to the other, do you have time?
Now I get it.
And I'm saying
What
you
is
don't.
time?
Right now, you don't have time. All you have is motion. Okay, you need two motions, a comparison, and you need memory. Especially time requires absolutely requires memory. Okay, so some people try to give us a definition of time. Here's one fellow says, if you figure out what motion is and what it is that is required to make motion possible, you get a better understanding of what time is. In doing so, you also independently derive the special relativity mathematical equations, including the Lorentz transformation equations. So the issue is whether we can figure out motion and the cause of motion. And I'll tell you the answer to that right away, okay? I know that by heart, okay? So I can tell you what motion is and how it was created. It's known as God. Some people say it's the devil, but yeah, those are the ones who set everything in motion, okay? There is no origin to motion any more than there is an origin to matter. I mean, to say the cause of motion, there is no cause of motion. You're talking about first cause again.
Well, because our assumption is that since matter can't become nothing and nothing can't become matter,
Yeah.
then, and since there is matter in motion, it always was in motion, it always will be in motion.
Correct. And the issue is, same for objects, for things, for matter. You cannot say that space turned into matter, or that matter can disappear like it does in mathematical physics and then turns into nothing,
Yeah,
whatever
we
nothing
we
is.
don't like that.
Yeah,
We
so
don't like that.
matter has always been there and will always be there because it has no way of turning into space into nothing, first of all. Second, it cannot leave space because space does not have a border for matter to cross. Not even God can escape space. And so matter has always been there. And if it's always been there, it's always been in motion. You can't say, how did motion start? What caused the start of motion? That's like asking, what caused the beginning of matter? That's only in
There is none.
in
Creation,
Big Bang
yeah.
creationism you have that, not in science. In science we laugh at that, There is no creation.
It's still weird to think of there being no beginning to time, right?
Yeah,
That still blows my mind.
You can't do that. You can't talk about the beginning of time or the beginning of motion or the beginning of matter. It makes no sense. Because what would be the mechanism? How would you explain it? Another fellow says, we can define our experience of time as it exists in our heads. I guess define it as our perception and recollection of continuity of sensory input.
We're talking about memory.
Yeah, but see, again, what you have here is if you're going to do it, if you're going to define it like that, like, my perception, does that mean that when you die, time dies for all of us?
That's a good question.
Did time die for us or for you only?
I think that's a valid question because if you kill all the observers, is there time? Because there's no memory, so you can't have 2 points.
No, but I'm talking about one guy because if I put it under my experience and I'm saying, well, for me, time is this, and does that mean that if I die, time dies for all of us because that's how I define time? So you have to define time in such a way that it's universal, that it doesn't depend on me dying. That's what I mean.
But it does bring up the question of what role does consciousness play in time?
It does because you need memory.
Yeah.
So in that sense, yeah,
That's
even a lion understands time.
That's a weird thing to think about. That time, is there a difference between time and memory? I guess.
Well,
if
you got
have
to
no
define
memory.
time in terms of memory,
Oh,
saying
not
like
memory,
a comparison of two motions. I don't think memory alone is a synonym of time, but you do need memory as an ingredient of time.
Yeah,
Okay? That's the way I look at it. Okay, another fellow. A lot of people on the issue of time, by the way. If time was physical and experience shared, we would all have slow days or fast days. what we have is one person telling another, my day went fast, and the other states my day was slow. Okay. Yeah. Again, you can't make it in
He's
these
got
terms.
a good point, boss.
Yeah.
I think time is relative. If I go to sleep, time goes pretty fast for me.
That's what Einstein's played around with. He tied himself into a knot because he says time is relative, motion is relative.
If you have 6 beers, time goes pretty slow.
Yeah, see, you can't define time or motion in terms of an individual in the sense of an observer. Because once you do that, then you're in trouble because it does become subjective in a different way than when you're comparing two motions. When you say time is two motions, if I die, we still have two motions out there. But if I say time depends on my memory, like saying if I'm God, if I die, time dies. Well, maybe for you, but not for me. So you can't define it in that subjective way. That's my point. You got to define time in such a way that you can use it in physics or understand it from a physical point of view. Okay? What do we mean by this word time? And I'm saying it's a comparison of two motions. Again, what did we see? You have distance traveled divided by speed. And what do you have? Motion divided by motion. It's a comparison to motion from a mathematical point of view, by the way.
Oh, it's been proven.
I'm just converting that into physics. I'm saying, well, what are you talking about? Motion divided by motion.
What are we talking about qualitatively, I guess?
Yeah, motion. Yeah, and it's motion divided by motion. That is the definition of time. That's what we mean by time. Do we use time in physics? Absolutely not, because we have no use for time. What are we going to do with time? What can you explain with time?
I guess
by saying
time itself
time.
we don't, but I guess memory. Because if we ever use a movie, then we're essentially using memory. But we're not talking about time itself, right? We kind of use it, but it's in the background.
But we have no use for time itself. Yeah. You can use it like maybe something like if you're going to talk about.
You don't use it. It's kind of like when you're watching a movie of a theory. Yeah, there's time because there's multiple frames and it's chronological, but it's like you don't care about the time itself.
Yeah, you could.
It's like a tool.
Maybe the only thing, like one context I can imagine is, again, paleontology. If you're going to compare, I don't know, the Cambrian against the Cretaceous or whatever, then obviously you're talking about different times. This one came before that one, in that sense only. Do we need to know that it's... Yeah, but do we need to know that it's 500 million years ago? No, we do not.
You might. I mean, sometimes you bring up the years when
but that's just to put it into context.
No, but it's also relevant if you're talking about like descendants of humanity. You bring that a lot. You talk about exactly when was the Neanderthal, when were the Neanderthals alive, when were we alive, things like that. You kind of want to know which one came chronologically before the other.
But mainly in that sense, it's mainly an issue. I don't care if it's 40,000 or 45,000 years ago. What we're looking at, did they live at the same
ballpark?
time?
Yeah, exactly.
That's the main point there. Okay, another guy. All these people with time. Okay, time is wear and tear. Well, yeah, that's very poetic. Okay.
I mean, we can see that. We can see that.
I'm the wearer of the tear, or both.
I think your clothes are the wear.
Yeah, that's very poetic. We can't use that as to try to understand what. I mean, we can say time is money. That's poetic. I mean, I can't say time is money as a definition that I'm going to be using to analyze something in physics or even in math.
I mean, you could, but it will get shot down pretty fast.
Yeah, time is money. What do you mean by that?
Yeah.
Okay, another fellow says time is a measure, which is not a thing. Yeah, but remember my context there when I said that time is treated as a thing by mathematical physics because they treat it as a medium. They say traveling through time, like if I'm cutting across cheese,
That through is
then they say
suspicious.
that what is gravity? It's the warpage of time. And you say gravity warps time. You're always treating time as a physical object when you give these physical interpretations. And that's what mathematical physics does.
The reification, right?
Yeah, and the question is that a physical interpretation or is that poetry?
Yeah.
I mean, what are we talking about? Is this a closing argument after you've presented your theory? Present your theory first, then you can use all the poetry you want at the end of your presentation and give us your closing argument in singing if you want. I don't care. But when you're giving your main presentation, you can't say, "Oh, what is gravity? Why doesn't the Earth fly out of the solar system?" Well, because we have this wall of warp time that prevents it. You can't
feel
use
bad
it like
for
that.
whoever gets crushed against the space.
Yeah, because the Earth is rolling around this curved space.
I feel bad for Australia.
I hope it doesn't squash you against the Earth.
Australia and Argentina are in trouble.
Okay, fellow.
That's a wall of text.
Yeah, but it says motion, change in location. He was trying to imitate my definition. You can't use the word change to define motion because change and motion are synonyms. Motion means change. Change means motion. They're synonyms. You can't use the word change. We don't use it. We're saying two locations, not change in location. Okay, that's the first clarification. Fellow continues, he says, are rotating objects within your definition not in motion? Okay, and I'm saying, well, what is this guy referring to? What would it mean for a perfectly symmetrical object to change orientation? Okay, I can imagine a universe with just two single piece objects, a triangle pointing face first towards the cube. The triangle is rotating. Listen what he's saying. He's saying it's rotating. It's in motion, right? About an axis that goes right through its face, okay? The minimum separation between the two objects never changes. And yet anyone watching the movie would qualitatively determine that something is changing frame to frame. Now imagine a second triangle added to this universe on the opposite side of the cube, also rotating. Rotating motion, right? But at a different rate than the first, okay? Someone watching this movie can compare the triangles to make a clock in their mind, a universe with time but no motion. We have a problem because the guy already starting saying, that something is rotating.
Yeah.
And so let me tell you what the issue is with what this fellow is suggesting, okay? Let me show you this. Here you have a little ball.
Uh-oh.
Let's assume it's a perfectly symmetrical ball made by God because he made it out of a single piece. It's not made of atoms. It's made out of a single piece, okay? Can you talk about the rotation of this object?
You can. You just can't tell.
No, you can't. I'm saying you can't because unless you identify one point, which I'm going to show here. There's your point, okay? There's your point, okay? Now, the only way I can know that this single piece object rotates if I identify a point and then move it around, okay? Then I can say, okay, now I can say it's rotating.
But we got a problem.
What is the problem?
There's a difference between something can or cannot rotate and I can or cannot tell if it's rotating.
Correct. And that's what's my next point. Okay. The point is, we're not talking about what I perceive. If the ball is rotating, it does so whether I'm alive or dead, whether I'm around or not. So the ball knows it's rotating. In other words. Okay.
I mean, God knows.
But right.
It's only God were the admin.
He's got all the knowledge. He's got to know. But my point here is the only way you're going to know that a single piece, whatever, in this case, a symmetric object such as a ball can rotate, right, is if you identify a point from a conceptual point of view. If you do not identify one point, you don't know if it's rotating. But the ball would know because the ball knows that this point is here, now is on the other side. So the ball knows it's rotating. I don't know because for me it's a symmetrical object. And so the issue here is, what is the system that you're analyzing? Are you analyzing the one-piece ball and you're saying it's rotating? How do you know it's rotating? How does the ball know it's rotating? The only way is you identify arbitrarily a point on its surface and it's got to move around. Then you know it's rotating. And then you do have motion because now, you have two locations of an object, right? And you can talk about time only if you compare that against some other motion of that same ball. Could be, before and after, for example. You take two arbitrary points, you memorize those points, and you say, I'm comparing this one against that one. Now you have time. Okay? So that's
my question.
That's
was a little weirder. Can you have a single piece cube? Because then you can.
Well, you can imagine. Okay, so let's imagine. So what? Okay, so you have a single piece cube, and
I feel like that's an impossibility because with that you could tell the corner from the edge, and then you could tell if it's rotating even though it's a single piece.
Yeah, and again, the issue is whether the cube knows if it's rotating, not if you know if the cube is rotating. We got to take the observer away.
Whether it's rotating or not, I guess is. Yeah. There are no knowers. It's rotating.
Correct.
No, that's all that matters.
The cube knows it's rotating.
Wait, what do you mean then?
Well, but what I mean by that is.
Why not
we're
just
not
say
looking,
it's rotating?
Because then people confuse it with the observer, and they say, "Well, do I know if it's rotating?"
You just clarify. It's rotating, but you don't know it.
Well, yeah, you can make that assumption. My point here is that even if I'm dead, if I'm not around, the ball knows it's rotating. If this point, right, is now on the other side, it knows it's rotating, or God, or whoever. But I may not know because I watch it and I say, "Well, it's a single piece. How do I know it's rotating?" I don't because I don't count. The ball knows it's rotating.
Why do we need a knower, though?
Well, that's where people confuse. That's where people introduce the observer, and there are no observers in physics. The ball knows it's rotating. That's physics.
Even the ball doesn't know. There are no knowers.
Well,
we don't need a knower.
How else are you going to phrase that?
We don't need a knower.
Yeah, we don't need a knower.
It's rotating. Don't worry about it.